Good day, everyone. I'm Sir RJ Layson, your math tutor and guide on this exciting journey through the world of numbers. In this video, we will discuss all about measures of position for ungrouped data, part 1, the quartile. When you say measures of position, it is a measure by which the position of the data determined through its value. It is the number that tells where the score stands relative to other in a set of data. It is used for quantity data that falls on some numerical variables. So the measures of position, there are three ways to solve for the measures of position. We can use general method, Mendel Hall and Sinch's method, and linear interpolation. Now, in general method, we've already used this one in our junior high school in grade 10. And also the Mendel Hall and Sinch's method. While linear interpolation, not usual siya ginagamit. So we will try to solve these two ways in solving the measures of position. Let's focus on this two. Now, let's go to the quartile of ungrouped data first. The quartiles are values which divided a list in order numbers into four equal parts. There are three quartiles which are denoted as Q sub 1 or quartile 1, Q sub 2 or quartile 2, Q sub 3 or quartile 3. Quartile 1, also known as the lower quartile, quartile 2, also known as the middle quartile, and quartile 3 is also known as the upper quartile. If the data are arranged in ascending order, the second quartile is the median of the data set. This means that 50% of the number of its data set lie below the middle quartile or quartile 2. The first quartile or the lower quartile is the median of the lower half of the data set. This means that 25%, this part of the number in the data set lie below quartile 1. While quartile 2, no, this one below quartile 2 is this one. And the third quartile or the upper quartile is the median of the upper half of the data set. This means that 75% of the number in the data set lie below quartile 3. So this one. So let's go to Mendel Hall and Sinch's method. Given a data set with number n of values, first, we just need to arrange the data set in ascending order. Next, we find the position in the data set. So in solving the lower quartile or the position of lower quartile, we will use the formula 1 times n plus 1 over n, then round up to the nearest integer. So we need to remember, class, in Mendel Hall method, no, in lower quartile, always round up sa class. Bisan unsa pa ang iyang decimal. For example, 2.5, round up always. 2.3, round up, so 3. 2.5, round up, 3. 2.3 round up, that is 3. Always siya round up in the lower quartile. And finally, look for the value of the lower quartile value in the data set. Next, in the middle quartile, we will use the formula position of the middle quartile 2 times n plus 1 over 4. So, to be exact man ang value na magawas for the middle quartile. So, we don't have to worry about this. While in the upper quartile class, the position of the upper quartile, we will use the formula 3 times n plus 1 over 4. And then round down to the nearest integer. And then finally, look for the upper quartile value in the data set. For example, you will have 2.6. So, round down ka, second position lang. Or 2.1. Round down ka, class, second position also. So, always in the upper quartile, round down to the nearest integer. Again, let's have a recall. In the lower quartile, round up always in the nearest integer. While in the upper quartile, round down always to the nearest integer. So let's have an example number 1. Alucard, a coffee shop owner, recorded the number of the orders of the different coffee drinks in a day. So we have here the coffee variation and the number of orders. In the Americano, we have 5. Black coffee, we have 8. Cafe, we have 10, espresso we have 9, double espresso we have 2, latte we have 5, macchiato we have 6, long black we have 7, and cortado we have 3. So first, we are going to find here the quartile 1, quartile 2, and the quartile 3 of the given data. First, we need to arrange the data values in ascending order. So let's arrange this one to the lowest data to the highest data. So we have 2, 3, 5, 5, 6, 7, 8, 9, 10. Next, locate the position of the lower quartile using the formula 1 times n plus 1 over 4 and round up to the nearest integer. So, since there are 9 values in the data set, we will use n is equals to 9. So, we have here, substitute the value of your n. So, we have 1 times 9 plus 1 over 4. So, 9 plus 1, we have 10. Times 1, we have 10. 10 divided 4, we have 2.5. So, we have here, the computed value is 2.5 becomes 3 after rounding up. Again, in the lower quartile, we need to round up class. Next, we need to find the lower quartile value of the data set. Since the lower quartile is in the third data element, so we need to count the which is the third data, first, second, and the third data. Therefore, the lower quartile or your first quartile is 5. Next, we need to locate the middle quartile using the formula. The middle quartile is equal to 2 times n plus 1 over 4. So, substitute the value of your n, which is 9. So, we have 9 plus 1, 10. 10 times 2, we have 20. 20 divide 4, we have 5. Then, we need to locate or find the middle quartile in the fifth data. So, we have here first, second, third, fourth, fifth. So, that is, therefore, the middle quartile is 6. And now, we need to locate the upper quartile using the formula upper quartile is equal to 3 times n plus 1 over 4 and round down to the nearest integer. Okay, we have here, substitute the value of your n plus 1, 9 plus 1, we have 10 times 3, we have 30. 30 divide 4, we have 7.5. Now, we need, since the computed value is 7.5, it becomes 7 after rounding down. Again, in the upper quartile, always round down class. And then find the upper quartile value of the data set in the, since the upper quartile is the seventh data, the element, so we will count first, second, third, fourth, fifth, sixth, seventh. So, therefore, your upper quartile is 8. Let's have another example. Find the lower and upper quartile of the scores of the 13 students in their 20-item math quiz given the data set. We have 4, 8, 12, 15, 1, 7, 9, 5, 9, 18, 16, 6, and 10. So find the lower quartile and upper quartile of the given data. First, we need to arrange the value in ascending order from lowest to highest class. So we have now 1, 4, 5, 6, 7, 8, 9, 10, 12, 15, 16, 18, 19. And then locate the lower quartile using the formula. Substitute the value of your n, which is 13 since we have 13 values in our given data set. So we have 1 times 13 plus 1 over 4. 13 plus 1, we have 14. And then 14 times 1, we have 14. 14 divide 4, we have 3.5. Okay, the computed value becomes, the computed value is 3.5 becomes 4 after rounding up. So, find the lower quartile value, which is the fourth data element. So, this one. So, that means your lower quartile is 6. Next, we need to locate the upper quartile using the formula 3 times n plus 1 over 4. Substitute the value of your n, which is 13. So, 13 plus 1, 14. 14 times 3, we have 42. 42 divide 4, we have 10.5. The computed value is 10.5 becomes 10 after rounding down. Upper quartile, round down class always. So, find the upper quartile value of the data set. So, it is the 10th element. So, we have here, the 10th element is 15. So, that means our upper quartile is 15. Now, in linear interpolation, no, in the Mendel Hall method, you just need in the in the lower quartile round up always, in the upper quartile round down always. That means that is not the exact value actually of the given the position of the ungrouped data of the quartile. In the linear interpolation class, we can identify the exact value of your position. We use the linear interpolation to know the exact value of the position is in decimal point. So how will we going to use this one? This is the procedure in using the linear interpolation. Step number one, we need to arrange the scores in ascending order. Step number two, locate the position of the score in the distribution using the given formula class in the Mendel Hall. And then step number three, if the result is decimal, proceed to the linear interpolation. Step four, we need to find the difference between the two values wherein the q sub k is situated. Step number five, we need to multiply the result of step number four by the decimal part obtained by step number two. And then step number six, we need to add the result of step five and to the smallest number of the in the step number 4 to get the value of your q sub k. For example, number 1, we need to find the lower quartile and the upper quartile given the scores of the 9 students in their mathematics activity using linear interpolation. We have their results are 1, 27, 16, 7, 31, 7, 33, 21. So we need to find the lower quartile. First, we need to arrange the values in ascending order. So we have 1, 3, 7, 7, 16, 21, 27, 30, 31. And then locate the position of the score in the distribution using the formula 1 times n plus 1 over 4. So substitute the value of your n, which is 9, since the data sets the total number of data set is 9. So 9 plus 1 times 1, we have 10. 10 divided 4, we have 2.5. Since the result is in decimal number, let's proceed to the linear interpolation. So step number 4, find the difference between the two values of your lower quartile is situated. So which is si 2.5 na locate siya in between ni 3 and 7 na data. Then q sub 1 is between the values of second and third. Therefore, we need to subtract the third and the second data. So we have 7 minus 3, we have 4. Then step number 5, we need to multiply the result of step number 4 by the decimal part obtained in step number 2. So we have 4 times the decimal part in step number 2 is 0.5. So 4 times 0.5, we have 2. And then step number 6, we need to add the result of step number 5 to the smallest number of step number 4. So 2 plus the smallest number in step number 4, we have 3. So 2 plus 3, we have 5. That means your lower quartile is exactly in the value, the exact value is 5. Therefore, the value of the lower quartile is equal to 5. Next, we need to find the upper quartile. So arrange the data set again in ascending order. So we have here the datas. Locate the position of the score distribution using the formula 3 times n plus 1 over 4. Substitute the value of your n, which is 9, since we have a total of 9 data values. So 9 plus 1, 10 times 3, we have 30. 30 divided 4, we have 7.5. Since the result is decimal number, proceed to the linear interpolation. We need to find the difference in the values of the q sub 3 ni siya class, which is the upper quartile. So let's change this one. This is, okay. So we have here located si q sub 3 7.5 class. So in between siya ni 27 and 30 nga data. So 1, 2, 3, 4, 5, 6, 7. 7.5 is here. No, in between the 7th and 8th data. So the q sub 3 is between the 7th and 8th data. Therefore, we need to subtract now the 8th data minus the 7th data. So we have 30 minus 27. So we have 3. Next, multiply the result of your step 4 by the decimal part obtained in step number 2. We have 3 times the obtained decimal is 0.5. So we have 1.5. And then add the result of step number 5 to the smallest number in the data in the step number 4 to get the value of your Q sub 3 or your upper quartile. So 1.5 plus 27. So the value of your upper quartile is 28.5. Example number 2. So there are the scores of 16 students. These are the scores of the 16 students of grade 10 Faraday in a 20-item test. We have 5, 7, 10, 15, 12, 14, 15, 18, 20, 26, 13, 14, 19, 8, and 20. Find the lower quartile, middle quartile, and the upper quartile using the linear interpolation. So the lower quartile, arrange first the data in the ascending order. So we have here the data set na. And then locate the position of the score. So we have the lower quartile over is equals to 1 times n plus 1 over 4. Substitute the value of your n, which is 16, since we have 16 data set. So 16 plus 1, we have 17. 17 times 1, we have 17. Divide 4, we have 4.25. Since the result of the decimal number, the result is a decimal number, let's proceed to the linear interpolation. So we have here the location of our 4.25. So we have here 1, 2, 3, 4. So 4.25 is here in between sa 8 and 10. So first, no, we can use this formula actually, class. The lower quartile, to be exact, class, is equals to the fourth data set, that is the smallest data of your in between your fourth and fifth data, plus the decimal, so that is 0.25, and then subtract the fifth and fourth data set. So substitute now. So our fourth data set is 8 plus 0.25 times 10 minus 8. So 10 minus 8, we have 2. So 2 times 0.25, we have 0.5 plus 8. So the value of your lower quartile is 8.5. Next, let's proceed to the middle quartile. So arrange the values in ascending order. So we have here the data set already in ascending order. Locate the position of the score in the distribution using the formula 2 times n plus 1 over 4. So substitute the value of your n, which is 16, since the total data of your given data is 16. So 16 plus 1, we have 17 times 4, times 2, we have 34. 34 divide 4, we have 8.5. Since the result is a decimal number, let's proceed to the linear interpolation. So let's locate 8.5. So 8.5 is here. So we have 2, 4, 6, 8. 8.5 is between the 8th and 9th position. So next, so the middle quartile is equals to the 8 plus the decimal, that is 0.5, times the 9th minus the 8th data set. So substitute the value. So our 8th data set is 14 plus 0.5. The 9th is 14 minus 14. So 14 minus 14, we have 0. 0 times 0.5, we have 0. So 14 plus 0. So we have the middle quartile is 14. Okay? Next, the upper quartile. So arrange the data values in ascending order. So we have now the given data set. Locate the position of the score in the distribution using the formula upper quartile is equals to 3 times n plus 1 over 4. So we have the substitute the value of your n, which is 16. So 16 plus 1, we have 17. 17 times 3, we have 51. 51 divide 4, we have 12.75. So since the result is in decimal number, proceed to the linear interpolation. Oh, let's locate 12.75. So we have here 2, 4, 6, 8, 10, 12. 12.75 is here. So we have here our 12.75. So upper quartile equals to the 12th data plus 0.75, that is your decimal, times the 13th minus 12 data. Substitute now the given values. So we have 18, which is our 12 data, plus 0.75 times 19, which is our 13th data, minus the 12 data, which is 18. So 19 minus 18, we have 1. 1 times 0.75, we have 0.75 plus 18, so we have 18.75. Therefore, the values of the upper quartile is 18.75. That's all for our lesson for today. Thank you so much for listening and watching. Please don't forget to like and subscribe and share it with your classmates and your friends. Thank you so much, everyone. Goodbye.